All right, thanks everyone for taking time to get to this webinar. Appreciate it. HashiCorp, thank you so much for inviting me to speak at this event. Truly appreciate that. Um, that said, let me start with this. All right. I'm just going to give a very brief overview of what MBRDNA is. I will tell you very briefly what we do. I'll give a high-level architecture overview of where we are and why do we need service discovery and why we went with Hashi's Consul. I will slightly dig in a little deeper about our Daimler Consul architecture, just so it gives us an idea of why we have implemented the way we have implemented it. I'm not going to go into in depth on service mesh, but I will just briefly touch on it because I just want to let people know, what the future is in MBRDNA and stuff. All right, so that's a very brief introduction of what MBRDNA is. MBRDNA is a Mercedes-Benz Research and Development North America. Once again, thanks everyone for making it to this. My name is Sriram Govindrajan. I am a principal engineer at MBRDNA Seattle. Let's see what we do at MBRDNA Seattle. MBRDNA Seattle Hub is a connected car division within MBRDNA. We are sort of like I put on a slide, we are the digital accelerator for Daimler. What that means is, in our existing generation of Daimler backend services, everything is in a data center architecture. So the main focus of our hub that was formed, I want to say about 2.5 years back, is sort of like make a nice, good developer productivity platform for people and move into cloud. Not for the sake of moving into cloud, but the idea is, the engineering teams can get new and exciting features fast and easy into what we call the Mercedes Intelligent Cloud. The idea is, with the current data center architecture, I'm not going to go into the details of what's difficult or what's wrong with it or anything of that sort. It's just that there are a lot of pain points there, and we want to address that with our new cloud architecture. The whole idea here is engineering teams themselves decide as to what goes in and when, right? We follow a lot of agile methodology. We evangelize DevOps culture within the company. What that means is, if I'm the engineering team, I not only own the source code of my services, but I own end-to-end ownership. What that means is, starting with the source code, I own the CI/CD process, continuous integration, continuous delivery, deployment. If my team is mature enough, there is nothing that's stopping me from going in for a continuous deployment, meaning like every single commit that I do, I can push it to production. Well, the whole idea is that, right? End-to-end ownership. So source code, CI/CD, deployment, what else? Maintenance, infrastructure, security, everything that goes along with it, right? The engineering team would own it. We're empowering the teams to go with it. Of course, there are a lot of experts from different walks of life in our hub here, as well as around Daimler. We help teams with a lot of best practice suggestions, and then of course they're welcome to talk to us in terms of their architecture, how they want to do things, etc., etc. But the whole idea is, we have formed a big community of developers around, where we share a bunch of do's and don'ts, or let me put it this way, we share a lot of learnings that came across from different teams, good and bad, so that people benefit from both good and bad, that the teams have done. What else I wanted to say? Yeah, like I said, the hub is about 85 people now. It was started about 2.5 years back. We do a lot of nice, good, cool projects. There is a lot of exciting new technologies that we get to work on. Of course, needless to say, MBRDNA is hiring. Please do check out MBRDNA careers, or reach out to me. I will put you folks in touch with the right people. Or if you ever want to talk about, what is it that we do, or have additional details and things like that, I will be super glad to have a conversation with any of you. All right. So with that introduction, let's get into a very high-level architecture of how things work out. Like I said, right, the whole idea of moving into cloud is not for the sake of moving into cloud, but make it a developer productivity platform. What that means is, if I'm the developer or I'm the engineering team, I want an easy and a reliable process to push my changes into production as soon as possible, right? I mean, that's the whole idea of making a developer productivity platform in the cloud. Um, of course, this diagram here that I have sort of like oversimplified it, but the idea here is, with all millions and millions of cars running on the roads and around the world, any of the backend services, that means, anything that the car wants details on, that's a backend service. All those backend services are running on a cloud today. Like I said, the previous generation, everything was running on or a data center architecture, but I think we have done a reasonable job in the past couple of years, in terms of moving from the data center architecture into cloud. I don't know the exact details of where we are with regard to the migration, but I want to say we are like very close to moving everything out of data center into cloud. That includes all regions. We have one for Americas, one in Europe, and then one in China. All right. So that said, any request that comes from a car is going to go hit what we call a geo tier. A geo tier is nothing but a giant VNet. Sort of like, think of it as like shared services VNet. That's all it is. A bunch of shared services that everybody needs is going to be in the geo tier. That's what is on that. I put Consul there, but I'm not going to go into the details of it now. But I have another slide, where we will talk a little bit more detail of what's what. Underneath geo tier, you're going to see a lot of environment tiers. I will go into details of what an environment is and such, but before that, I will tell you why we have multiple environments there and what is the connectivity between geo and environment, right? So let's talk about what the connectivity between geo and environment. Geo tier and environment tiers are VNet peered. So that means if I have an environment, every environment that I create is peered into the geo. That means there is connectivity between the two tiers. So if I have a service running on, let's say, one of the environments, I can easily talk to anything that is running on geo VNet, because there is network connectivity there. That said, let's talk about why we have multiple environments there, right? Remember, I mentioned earlier, that we were shooting for an end-to-end ownership of model for individual teams. What that means is we do not have a central operations team, right? To sort of like in let me put it this way, in kind of like old school or in other different companies that I've been part of, there used to be a central team that is responsible for not just operations, but for everything. Like sort of like everything has to pass through the central team before getting into production. That's good and bad with it. I'm not going to go into the details of it, but the idea is, in MBRDNA or in the current architecture that we're working on, we did not go with that model for various reasons. That's why we were big proponents of like end-to-end ownership. What that also means is, if we say the teams are going to be owning their environments, we should also provide a way for safeguarding the teams, in the sense, that I don't want another team to inadvertently mess with the configurations of my team, right? I mean, that is one of the criteria. In order to satisfy that is the reason why we went for this multiple separate dedicated environments for different teams. One of the reasons, there are multiple other reasons, but one of the reasons is that, right? So that means if I'm an engineering team, I will be given my own dedicated environment. What I do with it is completely up to me. Of course, I can refer to best practice recommendation. I can involve experts as and when I see fit. But the whole idea is I am responsible for the team. The engineering team makes calls in terms of what goes in that environment, what gets exposed, what are the different security aspects of it, what are the CI/CD portions that I follow to get things deployed, etc., etc. The whole thing lies with the team. That said, let's talk a little bit about what those environments are, right? Kubernetes was our platform of choice, that we chose for various reasons. There's a lot of goodness in Kubernetes. Of course, there's a lot of complexities as well, but majority of the people, wanted to go with Kubernetes. And of course, a lot of people in our previous lives have used Kubernetes, so we felt, this will be like a good solution for some of the things that we do there. So that said, we did not want to have like one Kubernetes cluster shared by multiple people, because people were worried about how things are going to work, who's responsible for maintenance, like operations, how will the cluster get upgraded, etc., etc., right? So in order to avoid all this, we started providing teams their individual Kubernetes clusters. When we went that route, we realized, kind of like having this manual process is going to be a painful thing. And of course, we didn't want to give complete control of creation of those Kubernetes clusters to the teams because of simple problems like, network overlap and things like that, right? So our infrastructure engineering teams own the network, so they kind of know, like who's got different subnets, and um, they handle things like, like how to make sure, there is no network overlap and things like that, right? As part of this effort, what we did was we created a self-service portal wherein teams can go fill in a bunch of details, hit submit. Half an hour, 45 minutes later, they're going to get their own Kubernetes cluster, and what they do with it is completely up to them, right? So we started doing it, because for various reasons, right? We said DevOps, we said infrastructure as code, automation, all those things, right? So once we put this process in place, as you can imagine, several people went ahead and created clusters the way they wanted it. And pretty soon we had like hundreds of clusters, right? It's good and bad. There is cost factor, but there is also no operations one, right? The teams are responsible for it, and then they were doing it. But what also ended up happening was, there are like multiple different clusters and different services running on them. So I'm just going to leave it at that, and I will pick it up later as to why we needed a service discovery, why we decided to use Consul and things like that. But just to sum it up, the whole idea is we have a geo tier VNet, and then we have environment tier VNets, which are paired with each other. Each and every environment is its own dedicated Kubernetes cluster, and we're using Azure for our public cloud offering. And we decided to use Azure's managed service, which is for Kubernetes. Azure Kubernetes Service, AKS, is what is our offering. All right, that said, now comes the question of why we need service discovery, right? I'm just going to go back to this slide very quickly because this is where I mentioned, each of these environments that I'm pointing out are separate Kubernetes services. AKS1, AKS2, AKS3, or cluster A, cluster B, cluster C, right, in its own dedicated environment. Now, think about if my let's say if I had one giant Kubernetes cluster, right, and then I had deployed all my services into it. Yeah, I'm going to make use of Kubernetes inherent service discovery feature to get things done. In technicality, I don't need a service discovery feature for that, right? Because Kubernetes provides inherently, I can use it. But in our case, that's not the situation, right? We have multiple Kubernetes clusters. That means I need to know where what service is running. So, which is where necessitates the need for service discovery, right? So we needed a single source of truth for where what is running, so that has become a paramount for our infrastructure. So multiple clusters, different running, different services, and some people run like, I don't know, 2 or 3 services in one cluster, or some people have like the idea of application groups where they run all the related services in a particular cluster. It goes by, the teams, right? But the idea here is multiple individual clusters running different services, and we definitely need a single source of truth to sort of like maintain the state as to where what is running. Of course, it's Kubernetes, the pods are going to get restarted, to maintain the desired state, et cetera, et cetera. So that means we wanted the single source of truth system to kind of hold the exact state of those services. Say, for example, if I have deployed a service, and then the pod gets restarted, I'm going to get a new IP. Say, for example, cluster IP. I want the new cluster IP showing on my single source of truth, right? So that is one of the main requirements for us, for having a nice, good service discovery solution. What else? That's what necessitated the need for service discovery. Like I said, multiple individual clusters running its own services. Some services are dependent. So we needed a single source of truth to tell us where what is running. Now, the question comes as to why we went for HashiCorp's Consul for service, right? For people that have already used Consul, this is kind of like a no-brainer, right? I mean, a lot of us in our hub have used Consul in our previous lives. So Consul is like a synonym for service discovery for us, right? I mean, that's what we've used in our previous jobs, so we were like, hey, the moment we started talking about like a cloud native service discovery solution, we were like, yep, let's go with Consul, right? It was super simple for us. But of course, we had to try and evaluate various other tools that are available, to show that, we have done sort of like a comparative study and such. So we started investigating into Zookeeper. I have not used Zookeeper in my previous jobs and such, so we started looking into Zookeeper, but then we quickly realized, that, man, there is too much of additional things that need to be done if we end up going with Zookeeper route, while Consul provides a lot of things, out of the box. So why not go ahead and use it? So it was a simple decision for us. It started out as a POC effort. We went into Consul, we decided, quickly that Consul is the way to go, and we were going to end up using Consul for it. Just to give you guys an idea of our data center architecture, we're using like Netflix Eureka model on that, right? So Eureka provides certain service discovery sort of features there, but again, that is not cloud native solution. So we wanted to go for a cloud native solution, and Eureka didn't fit the bill, which is exactly why we went for Consul, which is, like I said, synonymous to service discovery, right? Of course, Daimler is huge, and we have several teams distributed geographically, around the world, right? So we wanted a solution, that provides us good enterprise, reliable enterprise support, right? Again, Hashi fits the bill. Again, this comes out of a lot of us in the hub, that have used this product before, who have good relations with Hashi. And we've seen, how Hashi support works, et cetera, right? Based on all those, we decided to go with HashiCorp's Consul. Personally, for me, the best portion about Hashi tools in general, not just Consul, Hashi tools is, what I like best about them is the simplicity, right? I mean, Hashi tools are sort of like thin client. They're not like super heavy. They pack nice good features, but they try to keep it sort of like thin, right? I mean, it's not like heavily overloaded or anything of that sort. It makes your life easy. The maintenance on them is like super simple. So I would that's been my experience with Hashi tools, be it Terraform or Consul or Vault or anything such, any of those things, right? So that was again another reason that factored into Hashi's Consul that we ended up using. All right, so that said, now I want to dig a slightly little deeper into our Daimler Consul architecture, right? Like I mentioned earlier, remember there is a geo tier and then an environment tier. They are paired with each other, so there is network connectivity. So what do we have in our geo VNet? What we did was we created an AKS cluster, Azure Kubernetes Service Cluster at the geo level, and then we installed Consul servers on those clusters, right? So so in this case, it shows like 5 pods, if I can say, 5 pods of Consul server installed, which form like a quorum and stuff. They elect a leader and all that. Again, I'm not going to go into the details of it, but the idea is Consul server cluster is installed at the geo level, and then at the environment level, we have Consul clients installed, and each of those clients are installed as daemon sets. What that means is every single node in a client cluster is going to have a Consul client, right? And then the Consul clients are joined to Consul server cluster, making them a huge, giant, happy Consul family, right? I mean, they do their gossip, they have their Raft protocol, all the goodness about Consul. I'm not going to go into the details, but that's how we form a big, giant Consul cluster. Consul clients at the environment talking to joined to Consul servers at the geo tier. Once Consul clients are joined to Consul server, right, then suddenly this cluster becomes Consul aware. What that means is, I can just as easily do a DNS resolution and get to my services. Now, let's take a use case. Say, for example, I have deployed service A in cluster A, service B in cluster B, service C in cluster C. Let's say, for argument's sake, all these 3 services are owned by separate engineering teams, not the same team, separate engineering teams, right? And just to complicate the scenario, let's say there is dependency, just like any other enterprise will have. Let's say there is a dependency. Service A depends on service B, and then service B depends on service C. So let's say if we have such a dependency scenario. So environment A having service A, environment B having service B, environment C having service C. A depends on B, B depends on C. Let's say if that is our scenario, right? What ends up happening in this case is service A has got its own independent lifecycle. So the engineering team A, which owns service A, is going to be busy with their feature development, blah, 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 and then they're going to deploy their services on environment A, right? Likewise for service B and service C. Now, what happens with the dependency? So let's say service A can only be fully functional if it finds service B, right? In that case, what needs to happen is service A needs to know where service B is running. Now imagine life without this Consul server cluster, or imagine life without Consul. There is no way for me to know where this service is running unless I maintain this list, unless I sort of like have my own custom solution to maintain all this list, and then I worry about, how to keep it updated, etc. Right? So it gets super difficult, and imagine there are like about 200 plus services that we have, and the number is only growing. So it was impossible to keep track of what's what. So now with Consul, what happens is service A just makes a call to Consul and then says, hey, Consul, tell me where service B is. Consul gives back the IP address of wherever the service is running, and then service A can talk to service B because there is network connectivity. Remember we spoke about VNet peering, environment peered to geo in turn peered to, geo in turn peered to other environments. So with that, there is network connectivity, and that's how services can talk with each other. Service A talks to Consul, says, hey, tell me where service B is. Consul returns the address, it makes a call to service B, right? And then service B is like, it's got dependency on C, same way. Service B talks to Consul and then says, hey, where do you have service C running? It tells you where it is running, and then it returns the IP, and then that's how they talk to each other, right? Now, I said IP, it depends on how you have implemented it, right? So in each of these clusters, a lot of teams have implemented internal ingress. If the service that they want exposed is only within the clusters, like the case with the many enterprises, I would assume. So you can return an internal ingress, or it can return a cluster IP. I'm like, hey, my service is too small. I don't want to bother with internal ingress, etc. So I just want to expose my service as a cluster IP. So anybody that's got access into the cluster, into our environment, or rather into our, how do I put it, into our, what we call it, like Mercedes Intelligent Cloud, into our cloud environment, then they can they can easily get to the services. So it depends on how I have exposed my service. Some people have exposed it as cluster IP, which gets registered into Consul. Some people have exposed it as internal ingress, which gets registered into Consul. And then once you make a call to internal ingress, the ingress rules tells you where the service is running inside the cluster, etc. What else I wanted to say? So that's the whole idea of it, right? So Consul makes a call, or rather, the service makes a call to Consul. Consul client talks to server, and then it gives you what is running, and then that's how they make the call. What else? Let me make sure I've not been talking too long and I have enough time. All right. So that's pretty much what we have in terms of our architecture. I'm not going to go into details of it. I will leave some time for questions. And the last slide I have is about service mesh. We've not done much in terms of service mesh, but the only reason I put this slide is because, that's the future. That's exactly what we are going to explore next with regard to Consul. Because our initial idea was to move things from data center into cloud. And there was already a steep learning curve for people. One is getting used to Azure. Yeah, none of us knew Azure before we came into MBRDNA, so a lot of learning curve for us. That means a lot of learning curve for the dev teams as well. And then a lot of learning curve for Kubernetes for a lot of people. And in general, a lot of learning curve about cloud and the different processes, etc. So on top of it, we didn't want to add yet another layer for service mesh, because in my mind, service mesh is slightly complicated. It involves a little bit more time and effort, to understand how what's done. Of course, we all love the features, but we need to spend a little bit more time. So the primary focus was to get everything moved into cloud, and then start implementing features incrementally, right? So I think it's safe to say that we are at a state where things have stabilized, things have already migrated into cloud. A lot of things at least are, and teams have come up to speed with regard to how to operate and a few things like that, right? So now the natural progression is for us to go with the service mesh. I've already seen interest from a lot of teams, that want to proceed in this direction. And of course, as part of our POC, we tried doing Consul Connect, and from our experience, it was fairly simple. Just add like a couple of annotations, and life was, suddenly you have like your proxy talking to other proxy, etc. Right? So I just wanted to say that that will be our logical progression going on to the next thing. With that said, I will open it up for questions. Please shoot any questions you guys have. Thank you.
Thanks, Sriram. We did have a couple questions come in, so I got some lined up for you. One of the questions that came up was around your VNet peering. Are you just using the Azure native VNet peering?
Yes, absolutely. So like I said, remember I spoke about our self-service portal. As part of that job, what happens is every time a new cluster is created, yes, I mean, like I said, we own the networking portion, or rather the infrastructure engineering team owns the networking portion, so we know exactly what our IP spacing is going to be and what kind of subnets are going to be created, etc. And then as part of our automation, we do create the peering. That's exactly how it works.
Perfect, thank you. One of the other questions that came in was just asking about, well, it's twofold. So one, could you talk a little bit more, you mentioned it briefly, but maybe go in a little bit more about why you chose Kubernetes versus maybe some other options. And then also, do you have any like social or LinkedIn information that you want to share in case people want to ask you questions?
Sure, yeah. All right. Great question on Kubernetes, right? I mean, of course, Kubernetes is like kind of like the buzzword around the industry, right? I mean, everybody wants to work on Kubernetes. Everybody wants to do things on Kubernetes. So that is one thing. Of course, the other side of that is Kubernetes is incredibly complex. If it is not done right, then it makes your life a little miserable, right? What we did see was, I mean, there are Daimler being a huge enterprise, I mean, we see both sides of the spectrum. There are some teams and services that need something like Kubernetes because of the nature of their services and the size of the team, etc., where they have the ability to learn and kind of like manage the cluster by themselves. Whereas on the other side of the spectrum, we have smaller teams, I mean, who don't have much expertise, and I mean, they are forced to handle things on Kubernetes. That is not a very ideal thing, right? Of course, I mean, Daimler being Daimler at a big company, we have ways to mitigate this. I mean, they can always talk to people like us, I mean, who are in the middle, I mean, can help them, with some of the processes and such. But yeah, I'm guessing, as part of our next version, there might be some teams who will be like, yes, this is where we want to be. We want to continue with Kubernetes. We want to make it better, start using new features, etc. While there'll be others that might say, that, hey, this is incredibly complex for us, so help us make it simple for us, right? So the way I'm envisioning this to happen is, some teams will want to move to sort of like a shared cluster architecture where there is a central team which operates just the infrastructure portion of Kubernetes while the teams handle their services, while other teams might just go and choose like a different service that's available, right? Maybe, I don't know, Azure container instances or something like that, but we have to wait and watch, in which direction that goes.
Awesome, thank you. So we had a question come in about, so after you discovered that your services using Consul, how are the daemon sets in the different environments talking to each other?
The daemon sets in different environments are not talking to each other. That's, well, I lied sort of there, I mean, because there's of course Consul gossip happening. So I won't, rather taking Consul gossip out of the equation, what happens is your Consul clients are installed as daemon sets into your environments, right? So that daemon set, every Consul client is joined to your Consul server cluster. So your Consul client is only talking to your Consul server, right? So the moment you get, say, for example, you get like nslookup service name dot domain, right? Or service name dot service dot Consul or something like that, right? As soon as you get that request, Consul client is going to take it to the server, and then the server is going to resolve and get the contents back. But then the other portion of it is where the peering and the network connectivity comes in, which ensures that there is a connectivity between the two clusters. And say, for example, I have 10.1 and 10.2 on two different servers, right? And if Consul returns me 10.2 and I'm on 10.1, because of the network connectivity and peering with multiple hops, it can talk to those services.
Perfect, thank you. We have a number of questions coming in, so we may have to follow up afterwards just for timing. But next question that came up is, could you tell us a little bit about the size of the Consul cluster that you're running? Like, give us an idea of the scale.
Sure, yeah. Consul server cluster, I'm going to talk about both, right? Consul server and Consul clients. Consul server cluster is, I want to say it's a 3-node cluster. I mean, it's just like DS3 environments, I think that's what Azure calls them. Not super huge, but we do have like a 3-node cluster where we run the servers. Right now it's 5 pods that we are running. Scaling is not an issue. Of course, we can go for auto scaling or horizontal pod scaling or whatever, right? I mean, Consul supports a bunch of things. But so far, for us, Consul has not been the limitation in terms of, or a bottleneck in terms of resolving services and such. There are multiple ways to mitigate it, right? I mean, we use like time to live, etc. I mean, to kind of like get the services. So scaling has not been an issue for us now. And as far as client goes, like I said, it's a daemon set. So if you have like a 3-node cluster, you're going to have 3 Consul clients installed. If it's a 10-node cluster, you're going to have 10 Consul clients installed. Again, this is all automated. We don't have to go look into everything. We have proper alerts and everything set up. So if something fails, we'll get an alert as to what's going on. And if teams can choose to set alerts for Consul clients, and they can verify if there is connectivity, etc.
Awesome. All right, so I'm going to ask the last question here, and then unfortunately we are going to have to move on. But just so folks know, we do have Sriram's story posted on our website with Mercedes-Benz, talking a little bit more about how they're using it at the research team. Might answer some of these questions, but we'll also be gathering these and try to answer them for you either in the chat or at the end during the live panel Q&A. And I just want to be respectful of Sriram's time here. So last question is obviously, like, you went Kubernetes. One of the questions came up is, what was the driving motivation for you to use Consul versus something like Istio?
Great question. Istio is an amazing product, right? I mean, Istio has got tons of features, but what that also means is you need a fleet to maintain Istio. You need a rather large team to maintain Istio, right? I mean, at least that's what I've seen out of my experience. And I'm sure a lot of people that have used Istio would agree with me, in that it's good in features, it's feature rich, but the amount of features that you use versus the kind of maintenance and the team size that you need to maintain it is rather large. So like I said, our goal was to avoid having the central team to doing things. So we did not want to have any sort of effort, diverted in that direction, which is what sort of like, pushed us towards Consul. Consul, we have 2 things, right? One is Consul, like I said, it's lightweight, it's super simple. People understand what needs to be done. We have conducted a lot of brown bags and stuff like that internally, so that people come up to speed with why we need service discovery, how to do things with Consul, how to do service discovery resolution with the HTTP APIs or Consul prepared queries, a lot of things like that, right? Second thing is, we also have enterprise support from Hashi, so we kind of like divert a lot of questions that people have to Hashi, so that they're the experts of that product, so they can answer it a lot better than what us like internally can possibly ever handle.
Appreciate it. And again, we'll work on getting some of these other questions answered, but I do want to make sure we're staying somewhat on schedule. Sriram, really appreciate your time. Thank you so much for coming to talk to us. We're going to move on to our next speaker. It's going to be Eric Chen, who's a solution architect from F5. He's going to be talking to us a little bit about Big IP and how you can use Consul to conduct service discovery with Big IP.